Gotta catch them all. 9.5, a geometric series. All right. A geometric series is the sum of the numbers in a geometric sequence. Remember, a geometric sequence was just a list of numbers that when you multiply or divide to get to the next number. Well, a geometric series is when you take that list and you add them all up. Here's an example. 4, 8, 16, 32. Notice you're multiplying it by 2 every single time. They want you to go ahead and list out the first 10 terms and then add them all up. All right, so let's see how we can do that. Well, we can simply just list out the 10 terms because I know the next one's 64. And then you can just list 10, and that's not that bad to do. But what happens if I said find the sum of the first 100 terms? Then that would be a lot to list out all those numbers. So of course we have a formula. This is the formula for the sum of the partial sum of the geometric series. All right, this is the sum of the nth terms. This is the first term. The r is the common ratio. That's the number you multiply to get to the next number. Same thing, common ratio. And then n is the number of terms you want to add up. All right, so let's go ahead and do our example. We know the first term is 4. We know we're looking for the first 10 terms to add together. The common ratio is 2. You're multiplying it by 2 every single time. And then again, we're looking for 10 terms together. Using PEMDAS, let's simplify this. You would do the exponent first. Let me clean it up just a little bit. 2 to the 10th power is 1024. Go ahead and do the numerator. Subtract 1 minus 1024. And then do the division. Negative over negative is a positive, and then just multiply it by 4. And there we have it, 4,092. All right, so that's how we do them. Here's another example. 3, 6, 12, 24, dot, dot, dot. Oh, that dot, dot, dot is going to be a little bit tricky because I don't know how many terms are in there. And then I guess the last one I want you to add up is 3,072. All right, so there's the formula to add them all up. We do know the first term. It's 3. We do know r for both of them. It's multiplying by 2 every single time, so r is 2. And so there it is, but we don't know the nth term. I don't know how far along that list I had to go to get to 3,072. How many terms are there right there? To do that, remember this is a geometric series. So we're going to use our geometric sequence formula to figure out how many terms are there. We know the last term, 3,072. We know the first term, and we know the common ratio. What we are looking for is n, how many terms there are. So plug everything in, divide both sides by 3. Notice our n is in the exponents, so what does that mean? Logarithms. Use the definition of logarithms to change it to log form. On your calculator, you can go ahead and do this, or if you can use your change of base, you can do that on your calculator as well. Turns out that log base 2 of 1024 is 10. And then the last step is just to add 1 to both sides, which makes n equal 11. So it turns out that there are 11 terms there. And so what you do is you just plug 11 there. So we want to find the sum of the first 11 terms. And then just simplify everything. You should get 6,141. All right? Kind of fun. Summation notation. All right, so you've done this before. You can throw all of this into a calculator. If you have a new one, remember that there was a list of things you do if you had an old calculator. The new calculators are a little bit nicer and it'll do everything for you. If you don't have the calculator, you can go ahead and plug 1 in to the n, plug 2 in, plug 3 in, plug 4, 5, 6, and then of course the last number you plug in is 7. And then remember, the sigma makes you add them all up, and the final answer, 58,593. All right, that's it. Short lesson today. Go ahead and work on the homework.